Hey guys, okay, continuing with lesson 2.5. We're on example 4 now, on the bottom of page 9. And so now we're talking about stretches and compressions. So we're going to use the graph of f of x equals the absolute value of x. So I obtain the graph of g of x equals 2 times that absolute value of x. So first thing we're going to do is we're going to remember what our parent table is. And so we can see our parent function here is the absolute value of x. And so remember we used the numbers from -2 to +2. And then we took the absolute value of each of them. Remember that's just the distance the number is from 0. So -2 was 2 places from 0. -1 is 1 place. 0 is 0. 1 is 1. And 2 is 2 places. But then to make our new table so that we can graph the function that they gave us, we got to look and see what is that 2 right there going to do to our graph. Well, it's not inside with x, so therefore we know that this is going to be vertical. It's being multiplied times that absolute value of x, and anything that's being multiplied is a stretch or a compression. Well, remember, vertical does what it's supposed to, so what happens when you multiply something by 2? Does it get bigger or does it get smaller? Hopefully you said bigger. So that means this is a vertical stretch by a factor of 2. Now, if it tells you to, if it asks you to tell what the transformation is, I'm okay if you say it's a vertical stretch by 2. Yeah, I'm okay if you leave a factor of out of it, but you have to tell me a vertical stretch by 2. So what is that going to affect? Is that going to affect my x or my y's? Well, it's vertical. It's outside. It's not with x, so it does not affect the x. So x is going to stay the same, and our y's are going to change. But how is our y's going to change? Well, y does what it's supposed to, and it says 2 times the absolute value of x. So that's that a value, so we're just going to multiply by 2. So I'm going to take these x values right here, and I'm just going to bring them over, because we said nothing was going to affect our x. There's nothing inside those absolute value bars with the x. But these y's here, we're going to take and we're going to multiply them by 2. So the first one was 2 times 2, which is 4. Which is also what our last one is. The second one is 1 times 2, which is 2, which is what the last one is. And then the third one there was 0 times 2, which then is just going to be 0. And so there's our new parent table. And so all we have to do now is sketch this. So we got our x and our y axis. Let's draw on our points. So -2, 4. -1, 2. 0, 0, 1, 2, and 2, 4. So remember, absolute value is going to be a V shape, and it keeps going in both directions, so put your arrows. Now, it's hard to tell, did this actually stretch? But think about it. If nothing else, real quick, I'm just going to sketch the ones that are parent function here. I'm just going to put the points, so you can see, did my points vertically stretched? And they did. It's like if you take something from the top and the bottom and you pull it from above and below it, it's going to make it go up more. It's going to make it more narrow. Okay, so therefore it did stretch. All right, that's how we do vertical stretches. And if it had been a number less than 1, let's say if it had been a 1/2, then you do the same exact thing, except it would be a vertical compression. And when you graph it, you'll notice your graph gets wider.